Okay, this is our last note on chapter 4, and this is lesson 4.7, and here it's going to be about triangles and coordinate proofs. What the coordinate proof is talking about is we're going to use a coordinate plane. You kind of see I have a little picture down here. You have a y and an x, and we can take triangles like an isosceles, perhaps like this one, or a right triangle like this one, and we can use things we know about the coordinate plane to help us label parts of that triangle. And then we can use those parts or those coordinates to help us prove things about it. These especially work well with right triangles because we can then take the legs of each side of the triangle and place them right on the y and the x-axis. And you'll see exactly in a minute what I'm talking about there. And then we're just left with the hypotenuse not exactly on one of the axes. Exactly. So if we're going to do this, the steps to placing on the coordinate plane is, first of all, we use the origin as a vertex or center of the triangle. So here this would be our origin 0, 0. So for a right triangle, we just use that right in the center there. We can also place, if we have to, we can place our triangle right in the center of that. If it's an isosceles triangle, or even an equilateral triangle, we can kind of place it right in the center. Sometimes we can use it as one angle of the triangle, but it gives us a good idea or an easy way to label that triangle. So we always use the origin from that coordinate plane. And then we try to, if we can, place at least one part of the triangle on an axis. So here we have the right triangle. You can see we can do two sides. But even if we have an equilateral or an isosceles triangle, even though these two legs aren't going to work, but the base will. And it will sit right on the x-axis, okay? So keep that in mind. And then we always want to try, if we can, keep it within quadrant 1, which is over here, quadrant 1. And if possible, sometimes we might not be able to do that. And you'll see later on when we do some of these coordinate proofs with other shapes that sometimes you actually want to center things within different quadrants as well. And then we then use those coordinates, the x's and the y's, to make the computation simple. And let me give you some examples of that. So here's a right triangle. You can kind of see it. I just drew a picture of it here. And you see here's one leg, leg number 1, leg number 2, and then here's the hypotenuse, right? We have this right triangle. So then we know, let's just label these points A, B, and C. We know since B point is right on the origin, its x and y are 0, 0. And then makes it easier also. So if we go up to this coordinate of the triangle, this point, we then can call it 0 because we know the x is 0. But then y, we can just call it A. We can just call it a letter if we want to. And then we go to this point C of the triangle. We can then call this just a letter B because we don't really know what x is. But we can also say that y is 0 because it's the x-intercept. So that's you can see how easy it is to use this kind of thinking with right triangles. But if you had something like an isosceles triangle, and here's one right here, and you can see the other two sides that are equal. Okay, and I've kind of drawn some stuff in, and I'll explain why in a minute. But so we can have this one, the base of the triangle, right on the x-axis, right? So and we started at the vertex, so that we know this first point, if we call it D, we can call it 0, 0. Because it's starting at the vertex. Both x and y are 0. Then we have another point, F, and we can call that point A is how far on the x, and then 0 is the y, because it's not up or down, right? It's right on the axis. So these 2 points are easy, right? But then we go to this one, and we have to figure out, well, where exactly is this? But if you think about an isosceles triangle, and if we were to take this isosceles triangle and make it into 2 right triangles, and just draw a line down through the middle, make this a right triangle, you would then know, and if we said this is going to bisect it, okay, we would know that this is right in the middle. So then we could say that this point, as long as these two sides are equal, that this point is half of whatever A is, right? Hopefully that makes sense. And then we don't know what the y is, so we just call it B. Okay, so that's kind of an example There's a right triangle, easy. You just put it right on both the x and the y axis. The isosceles, you just easy to start the vertex. The x point on the bottom, the next x point is easy. You just call it a, and then y is a 0. And then we just use the fact that we could divide this into two right triangles. We call this a over 2 because it's half of a, the distance over. And then b would be our y. So if I show you an example of this, how this can be useful, kind of a proof, and you might say like this. So we have this triangle, and let me show you this here. So we have this triangle, and you can see we have some points on it, A, B, and C. Okay, and then we then have A starts at the vertex, right? It's 0, 0. And then we have this line in here, S and T. Okay, and we have these other points, and I'll talk about those in a minute. Okay, so we then look at what we're given. It says S is the midpoint of AC. So this one, we just have a point right here, and T is the midpoint of CB. Okay, and I want you to prove that ST, this line right here, is parallel to AB. And so we kind of have to look at where we got these points from. And you might see the points here, how I have them labeled, and I'm going to explain here what's going on. If you remember when we had the isosceles triangle, we kind of labeled the vertex 0, 0. Then we called this one A 0, right? And then we call this one up here like maybe A over 2, and then B. But here we don't have an isosceles triangle. We just have a, it doesn't tell us it's an isosceles. It could be, but we're not going to assume that. So instead we're going to do something different. We're just going to give them some general names, and we're going to try to give them names or some coordinates that help us. So here you see this one, we call this one is 2a. So for x, the coordinate, we call it 2a. I'm going to explain y in a minute. And then we know the y is still 0. Right? It's at 0. It's crossing the x. Okay, now this one, we're going to call it just another one, 2b, another point we don't know. And then 2c, another point we don't know. Because we can't do the right triangle here. Because we don't know if it's really, if it was an isosceles, we'd know. We could put a line down through here, a straight line, a midpoint, and we'd know they'd be equal sides, and then we could do a over 2. But here we just use 2b and 2c. The reason we're doing this 2a, 2b, and 2c is because we're using this midpoint formula. So with that formula, we're going to divide by 2. So here we're going to try to help ourselves and multiply these variables a, b, c by 2 so that when we do the math, it makes it easier. So let's look and see how that works. So if we want to find the midpoint, if you remember the midpoint formula, it's x, we add the x's, divide by 2, and then we get the y's, and we divide them by 2. And if you see, if we do that, so we call this x for coordinate s, okay, that's going to be midpoint between these. Okay, so we're going to take, here's the formula, right, for c. It's 2b for x, and then we just take 2b plus 0, we divide that by 2. Here, same thing, 2c for the y, and then plus 0 for the y, right, this is where it's lining up, these two, and then we divide by 2. In the end, we get, when we do all the math here, we get the coordinate is b divided by c. Okay, and then what we're going to do here, once we get these coordinates, is we're going to use the slope formula to see if they have the same slope, right? So if they have the same slope, they should be parallel, right? That's kind of what we're doing here. So then if we do t, the coordinates of t, we're going to do the same thing. So we're going to be 2a plus b, so 2a is right here, plus 2b, right, divide by 2, and then here we're going to get 0 plus 2c, right, to the y's lining up, divided by 2. There we get, then when we do that, we get a plus b is our x, and c is our y. We then do our slope for each line. So then for the st, this line here, we have for the slope, we get change of y over change of x. So here we have, so for this one we get c, right? And then c for that. So c minus c. And then we're going to do a plus b right here. And then we're going to do minus c for that. So in the end, we get 0. It's a horizontal line. That tells us pretty good, right? That we're right on with that. And then if we do AB, this one right here, right? We already have those points. And the same thing is change in y over change of x. So we got 0, 0 for the y, right? And then for the x, 2a minus 0. So again, we get 0 over 2a. That also is a horizontal line. So that then tells us we've proven using the midpoint formula and the slope to figure out that they have the same slope, 0 and 0, and they are both horizontal lines. So that means they're horizontal lines, so they are parallel. And that's an example I wanted to show you. We'll probably do one more in class. That's kind of our notes, and I hope that all makes sense. Make sure you get the idea of placing these on coordinate planes and being able to label these correctly. I think I'm going to do another example problem. It probably won't be on tonight. I might do it in the morning. Make sure you check these out and really think about these. These can take a little bit of thought if you're not used to them. Some of these little tricks about taking isosceles and turning it into two right triangles. And the right triangle, the two sides can go on. And here, using this midpoint formula and using the slope formula to figure out whether they are parallel. You could use that to figure out perpendicular lines as well, and you'll see that there'll be some other things in the next chapter that we use this for as well. So hopefully that makes sense. Add this to your notebook, and I'll see you in class.